temperature. So first one, what is the temperature? So what is the temperature? Thermal conditions of your body. Ability of your body to transfer of heat from one body to another body is called temperature, or the hotness or coldness of your body is called temperature. Hotness or coldness of your body is called temperature. So temperature means the thermal conditions of your body which determine thermal conditions of your body which determine its ability to transfer heat from one body to another body. Its ability to transfer heat from one body to other body. So from one body to another body, the other body is called. So other bodies, from one body to other bodies, is called temperature. It's called temperature.
Sir, September 1st నాడు కాలేజ్ స్టార్ట్ అవుతుందా?
Maybe no.
Okay.
Right. So thermal conditions of your body which determines its ability to transfer of heat from your body to other. So other bodies is called temperature, or the hotness and coldness. Hotness or coldness of your body is called temperature. Better. Hotness or cold. Coldness of your body is called temperature. So the hotness or coldness of your body is called temperature. To transfer of heat from one body to another body. From one body to another body is called temperature. So the ability of a heat, its ability to transfer heat. So its ability to transfer heat to other bodies, from one body to other bodies. From one body to other bodies is called temperature. Or the hotness and coldness of your body is called temperature. It is denoted by capital T or dt. It is a scalar. It is a scalar quantity. It is a fundamental physical quantity. Actually, this is one of the fundamental physical quantity. So actually, there are 19 members there. So mass, length, time, electric current, thermodynamic temperature, luminous intensity, quantity of matter, plane angle and solid angle. Okay, plane angle and solid angle are these are called supplementary fundamental physical quantities. Actually, this is one of the fundamental physical quantity. It is a scalar quantity. It is a fundamental physical quantity. It is a fundamental physical quantity. What is the fundamental physical quantity? The quantity which is independent of any other quantities. So fundamental physical quantity. It is a scalar quantity. It is a fundamental physical quantity. Right. Units. Units of temperature is MK system or CJ system. MK system is Kelvin. CJ system is centigrade.
So MKS, MSK में राशन.
MK system is Kelvin. Centigrade. So centigrade. This is the centigrade. Centigrade. CGS system is centigrade. So dimensional formula. So dimension formula, it is denoted. So RK theta. So theta RK, it is denoted by theta RK. Temperature denoted by theta RK. So MK system is Kelvin. CGS system is centigrade.
Sir, Fahrenheit.
Fahrenheit. This is the types of thermometers. Only types. So centigrade and Kelvin. So the thermal conditions of your body which determines its ability to transfer of heat. Its ability to transfer of heat from your body to other body. Transfer of heat to other bodies is called temperature. Okay. So temperature or hotness and coldness of your body. For example, one body is cool, one body is hot. So it is easy to identify because of temperature difference. Is that temperature difference? Right. It is denoted by capital T or dt.
Sir,
it is scalar quantity. This is a fundamental physical quantity. Units under dimension formula. Tell me, na?
Sir, what is the SI unit?
SI or MK same.
Okay,
SI is the system of international unit. MK is also same. SI or MK is the Kelvin. Is the Kelvin. Centigrade.
Sir, dimension formula akkada theta rasaru kada.
Theta is theta denoted by theta. Theta or K. Letters is sometimes some textbooks theta, sometimes is K. Temperature denoted dimension formula theta or K. K house of time is Kelvin, so denoted K. So theta temperature symbol some theta.
Okay, sir.
Right. Next one, what is the heat? What is the heat? Heat energy or heat. Heat energy or heat. Okay. This is the temperature. Small definition, temperature. Heat. Or heat energy.
Sir, is that theta?
This is the theta. Theta. Sin theta, cos theta. This is the theta. Simple dimension formula theta. Some textbook theta, some K or theta. Temperature dimension formula. Small t is the time actually. So temperature dimension formula theta or K. Right. Okay. Temperature clear? Right. Next one, heat. What is heat? Heat is a form of energy. It is a form of energy that transferred between two bodies due to temperature difference. For example, heat transfers from a body at high temperature to a body at low temperature. So heat is a form of energy that transfers between two bodies due to temperature difference only. For example, two bodies are maintained at same temperature without any transfers of heat. So two bodies are maintained different temperatures. Some heat flows from one body to another body. From a body at a higher temperature, so to a body at a lower temperature. So heat flows from 100%. Two bodies are maintained at a different temperature is must and should. Right. So heat is a form of energy. So first one, it is a form of energy. Form of energy. It is a form of energy. Transferred between two bodies due to temperature difference. Due to temperature difference. It is a form of energy that can transfer between two bodies due to temperature difference. Right. Right. First one. Due to temperature difference. It is denoted by QRDQ. So it is a non-mechanical work. How's are non-mechanical? Energy or work.
Sir, you are on. Sir, you are muted.
Sir, they are muted, sir.
Sir, mute video off.
Work. Work is a mechanical energy. What is mechanical energy, sir? It is a non-mechanical energy. Non-mechanical work. Mechanical work means, for example, work. This is the one body. Force is applied on a body. For example, body of mass medium. Force is applied on a body. Body moves through a displacement. Some displacement. Either forces are act. Either internal forces or external forces are. Okay. Either internal forces. Why is that not clear?
Yes, sir.
Yes, sir.
Sir, one on and off, sir.
Call is there actually. Now it's clear?
No, sir.
Yes, sir.
Again, rejoin.
Yes, sir. చెప్పండి సార్ అర్థమవుతుంది.
Clear.
కొంచెం బోర్డ్ క్లియర్ లేదండి.
క్లియర్ సార్.
బోర్డ్
ఓకే సార్, నౌ కరెక్ట్.
It's clear. Actually, now just only call.
ఓకే సార్, కనెక్టెడ్ సార్.
వాయిస్ కొంచెం లో అయింది సార్, ఏం కాదులే.
Clear?
Yes, sir.
Right. Either external forces or internal forces. What is the internal forces? Internal forces mean air resistance force, viscous force. These are the internal forces. External forces means just external force, either a mission or a hand or a human beings, anyone. This is the external forces. So external force acts on your body. So body moves through some displacement. So work must be done. Work must be done. So this is called mechanical work. Either engines or motors by supporting external forces. External force acts on a body, so move, some displacement, some change the position, changes its position. So some work must be done. Right. But in this case, without any external work, just one is the hot body, another cold body are kept in contact, heat transfers from one body to another body. Actually, these are types of three processes. Actually, heat transfers from one body to another body. There are three processes are there. One is the conduction, convection, radiation process. Okay, this is the transmission of heat chapter. Generally, without any external force, two bodies are kept in contact. So heat transfers from one body to another body. So after some time, these two bodies are kept in equilibrium. Equilibrium means are same temperature. Same temperature. So without any external force, so two bodies are kept in contact. For example, one is the hot body, another is the ice cube. For example, this is the one hot body. One ice cube is kept in contact one over the other. After some time, the ice also temperature is increases, hot body temperature also decreases. So this hot body temperature decreases, so ice temperature increases. After some time, both are maintained at same temperature, which is equal to the surroundings. So it is a non-mechanical work, right? Without any external work done.
Actually, we denote heat by delta, no sir, generally.
Actually delta dq, delta q, dq, all are same. Okay, right? Q, dq, or delta q. Okay, delta. This is a non-mechanical work. It is a non-mechanical work. It is a scalar. Work is a scalar. Same work or energy also scalar. It is a scalar. This is a scalar quantity. This is a scalar quantity. So right. So what is the units? So units of heat energy Q is MK system or SI MKS. MK system is joule. So in CGS system is calorie. This is the joule, J is the calorie. Therefore, 1 joule is equal to 1 calorie equal to 4.2 joules. 4.2. 1 calorie is equal to 4.2 joules. 1 calorie. This is the CGS unit is MKS. MKS unit is joule, CGS unit is calorie. So actual calorie in standard calorie, what is heat capacity, specific heat, actually in calorimetry chapter. So just what is the unit of heat energy is CGS unit is calorie and MKS unit is joule. So it is denoted by Q or dQ or delta Q. It is a non-mechanical work. It is a scalar quantity. So units joule in MK system, joule and CGS unit is calorie. So fifth one is the dimension formula for heat energy. It is a form of energy. Energy dimension formula same. Energy, work, heat energy, all are dimension formula same. So mL square T power minus. mL square, so T power minus 2. This is the dimension formula. So dimension formula is same.
Where it is derived or fundamental physical quantity?
This is also fundamental work or energy, not a fundamental. This is actually derived quantity.
Okay.
Not a fundamental. Work is a problem.
Derived from temperature.
9. Totally in universe also only 9. Mass, length, time. These are basic fundamental quantities.
Current.
Temperature, electric current.
4. Current, electric current, thermodynamic.
Intensity.
So this is the 4. 4 plus 7. 7 is the fundamental physical quantity. Included 2. I already explained in initial first from the beginning. Again 2. So 2 means plane angle and solid angle.
Complementary.
These are called supplementary fundamental physical quantities. These are different. Supplementary fundamental physical quantities. These two are depends on only for angles. Radian and steradian. These are units of plane angle and solid angle.
No dimensional formula.
Fundamental physical quantities. Remaining all physical quantities in universe derived physical quantities. Remaining all Only except these nine remaining all quantities are derived physical quantities. Derived physical quantities means which depends on other quantities. Other quantities means fundamental physical quantities. Okay, which depends on fundamental physical quantities. These are basic actually units on dimension chapter. So last chapter actually, right? So this is the heat energy dimension formula ml square. So T power -2 is the heat energy. But for example, you take two substances, supplementary. Tell me, Nana. Supplement angles, plane angle, solid angle only. Supplementary fundamental physical quantity, right? So two bodies are taken. One is the steel body, steel. For example, this is the steel. So another is the plastic. These two are maintained same temperature. These two are placed in same room. One room is placed in a room. So which is equal to the room temperature. Temperature also, each body is a room temperature, surrounding temperature, right? For example, room temperature, surrounding temperature, for example, 28 or 26, for example, 28 degrees C. So both are same temperature because of both are placed in same room. Okay, same room. So nearby the near distance, both are placed at near distance. Okay, not a near distance. Okay, taken is better. So one substance taken in one hand, either left hand. So another is the right hand. Okay. So after some time means 5 or within 10 seconds, 10 minutes, you observe the two bodies. Which body becomes cool? But both are same temperature, same room. You take, okay, na? So, but one body is taken in one hand, so another body taken another hand. So both are same hand, okay, na? Two hands. So one hand is is holding one hand. For example, this is the copper. Steel. This is the plastic. Plastic means open without right cap. So this is the plastic. This is the steel. Okay, na? Both are holding two hands with the two hands. Which body becomes cool? You feel actually.
Steel, sir. Steel.
You feel actually same temperature or different temperature. Which body more temperature? Which body less temperature?
Sir, less.
Sir, steel is less temperature.
Steel more temperature.
Steel is less and plastic is
Which plastic or steel?
Plastic.
cold.
Melting point, no, sir.
Same temperature,
hot,
sir.
sir.
Plastic less melting point, no, sir.
Plastic is cold.
My question. So both substance taken in two hands. So same temperature. Both are bodies not a different temperature. Both are same temperature. But both are actually you feel same temperature, or you observe different temperature, or which body is more temperature, which body is less temperature.
Same temperature.
Sir, both
Same temperature, sir.
metal more temperature.
Steel is cool. Hot is plastic is hot. Both are maintained same temperature. Place at same temperature, but you feel mustard should cool. Okay, na? Steel is substance is cool. So plastic is hot.
Sir, plastic absorbs more heat, sir, in less period of time.
Not absorb, not in one. Without any transfer of heat. Without any transfer of heat from plastic to surrounding. Plastic to surrounding. But this is a steel. So steel, each and every which is the transfer of heat from body to surroundings, body to surroundings, body to surroundings. So steel body becomes cool when compared to the plastic. When compared to plastic only. So not a other. So when plastic compared to the plastic, so steel becomes cool because of so more transfers of heat in steel. So when compared to the plastic. Okay. You observe. You can general observe. You take a general experiment. Okay. So one is the plastic body, another steel body. Any two different substances are taken. Okay. So one holding one hand, steel are taken one right hand, So plastic here is taken on another hand. You observe, okay, now 1 or 5 minutes. You observe in 5 minutes. Okay. So both are same temperature or different temperature. 100% different temperature. So steel is becomes cool. Plastic is some hot because of without transfer of heat from body to surrounding. But steel is heat transfers from body to surrounding. So steel becomes cool. Right.
సార్ అయితే అప్పుడు స్టీలే మళ్ళీ తొందరగా హీట్ ఎక్కుతుంది కదా సార్ ఒకవేళ హీట్ చేస్తే?
General, actually this is the process. Okay. But this is the constant without any change of temperature.
ప్లాస్టిక్ ఈజీగా మెల్ట్ అవుతుంది.
Melt అవుతుంది. Melt process, heating process same. High, but without any decreasing, okay, without transfer of heat from system to surroundings. You, for example, water is taken in a pot and plastic container. Plastic, okay, container. You observe which water becomes cool.
Steel.
Hot, sir.
Pot, because
Pot.
of forces are present in a pot. So heat transfers inner to outer side. So pot water is becomes cool, and comparatively plastic. Both are same room. Room also same. Room temperature is same. But in plastic container, water is hot, but in pot water it becomes cool because of fine forces are present in a pot. So heat transfers from system to surrounding. Okay, so system to surrounding, surrounding to systems. So heat is the transfer is present in a pot.
సార్ ఎక్కువ థియరిటికల్ ఉంటుందా హీట్? సార్
థియరీ క్వశ్చన్స్ ఎక్కువ వస్తాయి సార్.
Some part critical, some part
హీట్ ఎక్కువ థియరీయా?
theory, not theory enough, numerical also there. But compared to the mechanics part, it is easy. The easy means better. Okay, easy part, but not more applications. Not easy, not more of them. Mechanics part is the number of applications are there. Number of applications. But heat part is limited of applications. Maximum students first concentrate heat part because of more marks. More concentrate heat part, thermodynamics part. Thermodynamics is easy, 2 marks must to 2 bits. Heat also is kinetic theory of gases, 100% 1 bit, very easy. Average velocity, RMS velocity, most probable speed, all are easy. So more concentrate actually heat part, easy part. And applications also less applications. Okay, more applications, at least mechanics part is different. Not only 1 or 2 applications, infinite concepts. Right. This is the heat and temperature. Okay. What is the thermal equilibrium? Right. This is the thermal equilibrium. What is thermal equilibrium?
Equilibrium.
Two bodies are said to be thermal equilibrium if the two bodies are maintained same temperature. Same temperature is thermal equilibrium. If two bodies are said to be thermal equilibrium if the two bodies are maintained constant temperature or same temperature. So this is called thermal equilibrium. Right? Thermal equilibrium. So thermal equilibrium means two systems are said to be thermal equilibrium. Two bodies and two systems are said to be thermal equilibrium with each other. If they are same temperature, maintain same temperature. If they are at the same temperature, a constant temperature, same temperature. Same temperature. Same temperature. This is called thermal equilibrium. So, for example, these two bodies. So, this is the A, this is the B. So, for example, this is the 5 degrees C, 5 degrees. So, two bodies, two systems are said to be thermal equilibrium with each other if they are same temperature or constant temperature. So, constant temperature or same temperature, these two bodies are thermal equilibrium. Right. The concept of temperature is given by Girath of thermodynamics. The concept of temperature is given by the Girath law of thermodynamics. Actually, Girath of thermodynamics in thermodynamics chapter, just okay, concept of temperature is given by Girath law of thermodynamics. What is Girath law of thermodynamics? Right. This is called Girath law of thermodynamics. If two bodies are said to be thermal equilibrium, with the third. So A and B are must be thermal equilibrium. So A is thermal equilibrium to B, B is thermal equilibrium to C, C is thermal equilibrium to A, and all are same temperature. This is called Girath law of thermodynamics. It was found after first law, so this is called Girath law of thermodynamics. So F of PVT is equal to 0. What is the function? Function of what is the P? Pressure, volume, temperature. Not only temperature, either pressure, either volume or temperature also constant is 0. So if two systems are said to be thermal equilibrium with the third, A and B are constitute thermal equilibrium. A and B also are thermal equilibrium. This is called Girath law of thermodynamics. So A is thermal equilibrium with B, B is thermal equilibrium with C, C with thermal equilibrium with A, and all are same temperature. This is total cycle is constant temperature. This is called Girath law of thermodynamics.
Sir, here PVT means
A function of not a PVT, pressure, volume, and temperature also constant, same. Not only temperature, in the temperature same, not only temperature, pressure also same, and volume also same. Okay? In case of volume, in case of temperature, in case of pressure also remains same. So this is called Girath law of thermodynamics. So Girath law of thermodynamics, it is the concept of temperature. It is very, very important actually in thermodynamics. Just thermodynamics, Girath law of thermodynamics. Just a statement only write down. Whether if two systems A and B, write down first, write down thermal equilibrium, write down. Right. If two systems A and B are in thermal equilibrium, If two systems A and B are in thermal equilibrium with a third system C, then A and B must be in thermal equilibrium. Then A and B must be in thermal equilibrium. Then A and B must be in thermal equilibrium with each other.
Once again, can you repeat?
Right. If two systems A and B,
This definition is for thermal equilibrium or zeroth law.
are in thermal equilibrium. With
So
the
this
third-
definition is for thermal equilibrium.
No. Zeroth law. Thermal equilibrium already referenced. There are two systems only. Two
Okay.
systems equal is called thermal equilibrium. Along with C also zeroth law. If two systems A and B are in thermal equilibrium with a third system C, if two systems A and B are thermal equilibrium with a third system C, then A and B must be in thermal equilibrium. With each other. It's
Sir?
called zeroth law of thermodynamics. F of PVT equal to 0.
సార్ సార్ థర్మల్ ఈక్విలిబ్రియం లో ఉండాలంటే ఓన్లీ మాక్సిమం బాడీస్ 2 సార్?
Thermal, not even 2. Anyone, for example, same temperature, this is the thermal equilibrium. And for example, 2.
ఓకే సార్.
More than 2. For example,
అంటే
some
సేమ్
body-
టెంపరేచర్ లో ఎన్ని బాడీస్ ఉన్నా కానీ థర్మల్ ఈక్విలిబ్రియం ఉన్నట్టు.
thermal equilibrium means same temperature.
ఎన్ని బాడీస్ ఉన్నా కానీ థర్మల్ ఈక్విలిబ్రియం ఉన్నట్టు కదా సార్?
There is a same temperature. This is important. Thermal equilibrium means same temperature. If not only two bodies, so number of bodies are there, number of bodies are present, but all bodies are same temperature. It is a concept of temperature. Zeroth law of thermodynamics. It is a concept of temperature. Next, actually, original topic in thermodynamics chapter, just only state of thermodynamics, zeroth law of thermodynamics. Actually, it was found after first law. So they named as zeroth law. Right. So next one is thermometry. So measure of temperature required. Measure of temperature. Temperature is a measure of temperature is called thermometry. Measure of temperature. So the measure of temperature. Temperature is measured by, there are two types. Construction thermometer.
సార్ మీరు మ్యూట్ లో ఉన్నారు సార్.
So construction and calibration thermometer. There are two types. Construction and calibration. So there are two types. Construction So calibration. There are two types of thermometer, na? Construction and calibration thermometer. Construction thermometer, it depends on some physical properties like pressure, volume, that changes with the change of temperature. That changes, change of temperature. Temperature also
repeat
changes, and volume also changes. So this is called construction thermometer. So there are two methods. What is the measure of temperature? What is the thermometry? So measure of temperature. The measure of temperature is called thermometry. There are two types of thermometer. There is a construction thermometer and calibration thermometer. So construction thermometer means it depends on some physical properties like pressure and volume that changes with the change of temperature. That changes with the change of temperature is called construction thermometer. Calibration thermometer. So calibration thermometer, it depends on some numerical values. Numerical values means two fixed points are there. One is the fusion of ice or melting point of ice. Melting point, another steam point. Melting point, steam point. So there are 2 points. So melting point, steam point. Actually temperatures, to measure temperature by different scales. Actually 5 scales are there. One is the centigrade scale, Fahrenheit scale, Kelvin scale, Newman scale, Rankine scale. There are 5 scales there. For example, centigrade scale. For example, this is the one thermometer. For example, this is the one thermometer. So actually thermometer, types of thermometer, actually 7 thermometers are there. So first one is the liquid thermometer. Liquid thermometer means mercury thermometer. This is the thermometer. So thermometer, right. So actually made of, for example, glass or some plastic also glass. This is the one capillary tube is present inside the thermometer. This is the capillary tube. What is the capillary tube? Capillary tube means this is made of glass. Both sides are open with a small bore. Bore means radius is very small bore when compared to the length. When compared to length, very small bore. It is small radius. It is small hole. This is called capillary tube. So this is a thermometer. Thermometer, actually one capillary tube is present inside the thermometer. This is the one side is coated with black. It is kept in, for example, first one ice. Is ice. This is for example ice. So inside the capillary tube filled with the mercury. This is the mercury. This is the mercury. Filled with mercury. Mercury. So first one, this thermometer is kept in ice. Ice. So the mercury level falls to 0 degrees. It is taken as LFP. LFP. For centigrade scale, this is the centigrade. It is found by Celsius, so Celsius scale. Fahrenheit scale, Newman Kelvin scale, Newman, different types of scales are there. So this is actually Celsius scale. So it was found by Celsius, so Celsius scale. There are 2 fixed points. One is the melting point of ice. This is the melting point. Melting point. So melting point of ice at 0 degrees C, which is taken as LFP, lower fixed point. The lower fixed point. So next one, it is kept in hot water. So same model is kept in hot water. Right. Boiling water or hot water. Or steam water. This is the hot water. Right, this is the capillary tube. Right. The mercury level is increases. Mercury level is increased. This is also steam point at 100 degrees. It is taken as LFP. UFP. Upper fixed point. Upper fixed point. So it is taken hot water or boiling water the mercury level is increases. Temperature increases, so mercury level also increases up to 100 degrees. Up to 100 degrees. Right? The scale this is called, it is taken as UFP, upper fixed point. That's formed by Celsius. So Celsius, it was is identified by lower fixed point is 0, upper fixed point is 100. The scale is divided into 100 equal parts. 100 equal parts. These are 100. So 0 to 100 equal parts. Each part is corresponding to 1 centigrade. The lower fixed point is 0, upper fixed point is 100. It is scale. Actually, this is the lower fixed. The difference between these two is called fundamental units. So fundamental units is divided by 100 units. 100. So each unit, each degree is corresponding to 1 centigrade. This is called centigrade scale. Okay, or Celsius scale or centigrade scale. So next one is the Fahrenheit also. Fahrenheit is different. So lower fixed point is actually 32, upper fixed point is 212. So Kelvin scale is divided by 180 equal parts is Fahrenheit scale. Kelvin scale, so lower fixed point is 273.15. Upper fixed point is 373.15. Next one, next write down each and every scale. So it is divided by 100 equal parts. So next one, Romer scale is lower fixed point 0, upper fixed point is 80. So 80 parts. So next one, Rankine scale 492 and 678. So is equal divided into 180 equal parts. So each and every scale, so lower fixed point and upper fixed point. So melting point of ice is it is taken as lower fixed point. So steam point is taken as upper fixed point. There are two fixed points. So upper fixed point and lower fixed point. So lower fixed point is LFP, upper fixed point is denoted by UFP. Upper fixed point. The lower fixed point. Right? Right. So first one, so right. Construction thermometer. Construction thermometer. Use of mercury. Mercury also increase the level is the temperature method. So this is the first. What is the mercury? Mercury also, for example, without mercury, without temperature. So for example, 0 degrees C, mercury falls 0 degrees C. So next one, temperature increases, mercury also increases. The level of mercury increases. So temperature increases, mercury level increases. This is the liquid thermometer. This is actually liquid thermometer. Right. So right on construction thermometer. So it depends on some physical properties. It depends some physical properties. It depends on some physical properties like pressure, volume. It depends on some physical properties like pressure, volume, etc. Right? Etc. Abide. Types of thermometer. You first write down. It depends on some physical property that changes with the temperature. Without charting about. Without charting. It depends on some physical property like the pressure and volume changes that changes with the temperature. That changes with the temperature. So this is called construction thermometer. Now is next one, calibration thermometer.
So that changes with
change of temperature. That changes with the temperature. That changes with the temperature. Right. Next one, calibration thermometer. Calibration thermometer are calibrated calibration thermometer are calibrated some numerical values. Numerical values.
What's sir? Calculated?
Some numerical values. And so that you have numerical value. Numerical values. So there are two fixed points. Of the types write down are better. Okay, no problem. There are two fixed points. There are two fixed points. There are two fixed reference points. There are two fixed reference points. There are two fixed reference points. First one is ice point. First one is ice point. Ice point. This is ice. Ice point. Ice point means melting point of ice. This is a melting. Melting point of ice.
Sir, it means lower fixed point, sir.
Right. Ice. I don't subheading next draw diagram. Ice point. Melting point of ice. 0 degrees C. It is taken as lower fixed point within the bracket LFP. It is taken as lower fixed point within the bracket LFP. Ice point, melting point of ice at 0 degrees C. So it is taken as LFP, lower fixed point. So this is the only for Celsius scale. So lower fixed point is different for different scales actually. It is not a fixed 0 degrees C. The Celsius scale 0 degrees C. Right. LFP, lower fixed point. Second one is steam point. Steam point. Steam point. Boiling point of water is called boiling point of water. Boiling. Boiling point of water. Boiling point of water at 100 degrees C. Steam point. Boiling point of water. Boiling point of water. It is taken as upper fixed point at 100 degrees C. At 100 degrees C. It is upper fixed point. It is upper fixed point. UFP. Right. Actually, the intervals between LFP and UFP is called fundamental intervals. Fundamental intervals. Okay, next. So draw diagrams. Next one is the thermometer. The lower fixed point is 0 degrees C. LFP. This is the UFP. This upper fixed point is 100 degrees C. So this is the part is the how many parts? 100 equal parts. Right. Is the 100. So actually these are 100 equal parts. That is the intervals between lower fixed point and upper fixed point. Okay, is 100 parts, 100 equal parts. Each part is corresponding to 1 centigrade scale. So next, write down centigrade scale definition, Fahrenheit, all our definitions write down. Just only one model. So melting point of ice, the boiling point, or steam point,
Good morning, sir.
Sir, sir,
madam?
sir, good morning, sir. 10:10.
Time?
Sir,
Oh, time over.